Welcome back to Geometry, Chapter 6, Section 2 of this book. So what we're going to be talking about is parallelograms. Excuse me, my nose is itching. So how I think of parallelograms, have you ever seen an old picture frame that has gotten rickety and you can push it where the edges aren't staying firm anymore and it's being pushed around, or maybe an old box. My kids once did a craft where they made these, craft to take home to your mom kind of thing, and they weren't stable and the box would go like that. So in a parallelogram, opposite sides are parallel, meaning they're always the same distance apart. They're like railroad tracks, they're never going to cross, they're never going to spread out, they're always going to stay the same distance apart. And that's the symbol for it. You have these two triangles, meaning those two are parallel, and then double triangles here, meaning those two are parallel. So here we have four theorems. So this is it. If it is a parallelogram, see I put the little parallel markings in the ogram, then opposite sides are congruent. So this side equals that side. I think of this like pasta, and that these are knives, and they're going to cut the pasta to make it the same length. Little cutters. But if that helps, use it. If not, toss it out. Okay. If it's a parallelogram, opposite angles are congruent. So this angle equals that one, and this angle equals that one. And that kind of makes sense, because as it bends over, you can see those opposite angles being the same size. So they're the same as the one across the X from it. Okay, if it's a parallelogram, then consecutive angles are supplementary, which means two in a row add up to 180. So 1 and 2 is 180. This one and that one's 180, this one and that one is 180, this one and that one is 180. They're all, if you take two that are next to each other, add them up, it's 180. The next one is, if it's a parallelogram and you draw diagonals across it, the diagonals bisect each other. So this half of this little line and that half is the same, and this one and that one's the same. Now the two are not the same. As you shove it over, if we kept shoving this one over, this one would get longer as that one got shorter. So it would be the same if it was a rectangle. But when we shove it over, there's going to be a long one and a short one. Alright, so here's something we could do with it. This is a parallelogram, and we know that the line FG equals 5 and the line KG equals 3. And they want to know, well, what is JH? So JH is the bottom one. What do you think? Well, remember, 5, these two have to be the same. That one right there. So this is 5. That's 5. And then JK is this. We know this half is 3. So we know this half is also 3. Because they bisect each other. It's like that one. They both have to be 3. Okay, here's another parallelogram. It might not be in real life because I didn't draw it that good, but you can use your imagination. Okay, so all we know is that this angle is 70. And we want to know the measure of angle R. What is it? That's right, it's 70. Because angles across from each other are the same. Now what's angle Q? Well, we can figure it out because angles in a row are 180. So this one is in a row with these 70s. How much would you add to 70 to make 180? You'd add 110. So that one's 110 and that one's 110. Okay, here's another one. This angle is 3x, that one's 120. What is x? Well, we know 3x plus 120 is 180. And we can solve for x by doing the opposite. We start with what's further away from x and do the opposite. It's being added to 120, so we do the opposite, subtract 120. What we do to one side, we do to the other. These cancel out. You bring down what you didn't mess with, the 3x and the equals. 180 minus 120 is 60. Now why is x not alone? It's being multiplied by 3. So we're going to do the opposite and divide by 3. What we do to one side, we do to the other. These cancel out. 60 divided by 3 is 20. And see, that's why you take geometry after Algebra 1, so you get that year of practicing your Algebra 1 before you go to the really hard class, Algebra 2. Alright, so here is a proof. Yay! We love proofs. Okay, we have two parallelograms. We have one here and one there, and they're on top of each other. Okay? So we are given that ABCD is a parallelogram, and we're also given that AEFG is a parallelogram, and we are to prove that angle 1 equals angle 3. So first, you always write your given, and write the reason why you're allowed to write it down is given. Then, number 2, we can say that angle 2 equals angle 3, and angle 2 equals angle 1, because opposite angles of parallelograms are congruent. Then we can say 1 and 3 are congruent because, you know, my 3 fingers, if 1's congruent to 2 and 2's congruent to 3, oh no, hold on. Sorry about that, I didn't realize my ringer was on. I had my timer so I wouldn't go over. Go back. If 1 is equal to 2 and 2 is equal to 3, then 1 equals 3. Okay? So transitive property, remember that one has a hand symbol, the transitive property. And we have proven that 1 is congruent to 3. Alright, sorry about that ringing. Math is great. See you next time.